Hey everyone, it's Jonathan, Director of Community here at Ninja. And oh my gosh, we have the man himself, Mikey. Mikey O'Toole, thank you so much for being on. Thank you for bringing this suggestion for a good live stream topic. Man, my timing is weird. I think it was about a month ago that we had David on, and he went through some tips and kind of his thought process around how he writes PowerShell. And as a follow up to that, you were like, I could probably give some helpful information here around all the tooling and things that go around that concept. So I'm very glad that you brought this up and that you're up for doing this. And thank you for just being so active, being so helpful. You're amazing. Thank you for taking time.
No worries. Thanks to Ninja for providing the community and the kind of core thing that we all gather around and that brought us all together to do this crazy stuff.
It's been amazing, and thank you everybody who is on. Rapunzel's giving you some shade here in the chat, but thank you everybody who is taking time to hop in here. You all are the best, and this community is crazy, continues to grow and be super active. As always, if there's any suggestions for other streams we could be doing, or just other things in general, ways that we can make the community even better and more helpful, let us know. But Mikey, I know there's a lot of ground you want to cover, and we have a lot of resources to share.
Yes.
Where would you like to start? We also have questions too. You brought up a good point of like, hey, we should give people an opportunity to ask questions ahead of time. So we have those kind of teed up for you too. But what's the best way that you would like to do this?
So I have a virtual machine ready. I'm basically going to kind of, start by walking through the tools I use, why I use them. I'm going to set them up live on stream because, that's never gone wrong and never killed anyone before. I'm going to talk about Visual Studio Code, which is the editor I use when I'm, writing PowerShell, C#, the occasional batch script whilst, saying 7 Hail Marys and, flogging myself ritually for touching batch, but I have to do it occasionally. Git, DevOps kind of tools. And yeah, there'll be some recommendations and there's a lot of links to go alongside this. So there'll be a list of links at the end. And yeah, hopefully a little bit more of an insight into the tools I use to make writing PowerShell easier.
This is amazing. You're giving a peek behind the curtain. So
a
you
little,
can see,
yes.
Yeah, not too much. But yeah, it is funny. Whenever I look to message you in Discord, I typically do see, oh, you're playing, whereas other people would be playing Spotify or games, you're playing Visual Studio Code. So
yeah, sometimes that is a shield. So the way the playing Visual Studio Code thing works, it's actually one of the Visual Studio Code extensions. It's not on the list, but it's very grabby. So even if I'm secretly sat here playing Horizon Forbidden West, the Visual Studio one takes precedence. So sometimes I can leave Visual Studio Code open and happily game without anyone knowing.
Another secret and tip.
Yeah, that's why everything I do is slightly late. It's actually because I'm gaming most of the time.
Amazing. Awesome. Well, hey, I'm going to get my mug off the screen, and I can pull up your screen that you're sharing,
cool.
And let you take it away.
So first things first, this virtual machine is a nod for Robin, Ramble and Romp. When I did a webinar a while ago, she said make it Spider-Man themed, and I didn't have time. So this time I took the time, and Miles Morales is logged into his nice little Spider-Man computer, all for Robin.
Amazing touch.
So I'm going to kick it off. I'm going to install Visual Studio Code. If you've interacted with me, you'll know that I'm a little bit of a Winget enthusiast. So I'm going to install Winget from install Visual Studio Code from Winget. And I'm also going to install the new version of PowerShell because Windows comes with PowerShell 5.1, latest version is PowerShell 7. I'm not going to do anything that requires PowerShell 7. It's just part of my setup. It's, VS Code, PowerShell 7, and Git. And we wait a little bit for it to do its install-y things. Thought about installing these in advance, but I figured that starting from a blank slate might show people some stuff they haven't covered in setting this stuff up. So here we go. We're waiting. Let's parallel.
You also just like doing things without a net. You just
a little bit. Yeah, I'm gonna run in PowerShell in parallel though. I didn't write down the package name for Git in advance. That one I should have done. There we go. Cool. So Visual Studio Code is installed, PowerShell is installing, and Git is installing.
Are there going to be any? I'm not as familiar as I should be, but are there any like with these tools that you're using? Are any of these controversial in that like people have their other type of tool that they really prefer? Like, is there?
There are tons of people who have a hard preference on the editor. That's probably the only one. I can't really see anyone in the IT environment sitting there saying, when talking about Windows admin, at least sitting there saying, oh no, I do all my automation in Python. There are plenty of languages with great points, but really PowerShell is what you use for Windows automation. But yeah, editors, definitely people have their editor choices. There'll be as many people sat there going, ugh, Visual Studio Code, that's bloated and horrible. I use Notepad. There will be the people out there still using PowerShell ISE, Microsoft's PowerShell editor. It's worth noting that Microsoft have deprecated ISE. It gets no improvements, no changes, and just for the kicker for anyone still using it, it doesn't behave like PowerShell. Just waiting for Git to finish up, and then we have a basic development config. Just going to touch briefly on something that Microsoft added in the latest Windows 11, which is called Dev Home, this little weird Microsoft-y style house icon in the Azure style where it's just a ribbon and they think it looks like something. I don't. Dev Home is kind of cool. We've started using it a lot because you can package up your development environment. So you can say, install PowerShell, install Visual Studio Code, install Git, and you can actually package that up as a JSON file and feed it to Dev Home on your developer computers, and it will sandbox stuff on its own. So it creates this nice little development area within your computer that has all the tools you need, but isn't actually on the main machine. It's not interfering. It's all sandboxed in its own storage. Very cool thing that they added. And then you can add these cool widgets to monitor stuff like GitHub repos or Winget package releases. So yeah, I haven't set it up on this because it felt like a bridge too far, but it's well worth people looking into if you do a bit of script development. And close that down nice and slow. There we go. We're good. So let's bring up Visual Studio Code, give you an idea of what it looks like when you first launch it. If you haven't seen it, some of you I know spend almost as much time in Visual Studio Code as I do. I should have given this virtual machine more processors. I'm feeling the lag.
I don't know anything about that. We've got backups and bandwidth coming up on Friday, which I forget who it was. Probably someone active here in the chat that
have you got enough bandwidth?
Pointed out last year we were lacking on the bandwidth part of that.
Cool. So Visual Studio Code installed. Out of the box, it doesn't really come with much that's particularly helpful. It'll do a fair job at recognizing some common languages, and it'll recommend some extensions to you as you go. but on the whole, it's fairly agnostic. So there's a couple of things we want for the purposes of PowerShell development. We want Microsoft's official PowerShell extension, because that adds a lot of syntax highlighting and some understanding of the PowerShell language and how to format PowerShell. Extensions have this new get started thing. This has only been added in the last couple of VS Code versions, which will help you do things like install PowerShell 7, choose which PowerShell you want to use, create new files, and does a whole bunch of handy stuff. Visual Studio Code has this ISE mode, which makes it look and feel a bit like ISE. So if you are a hardcore ISE user and you think, I can't change, try Visual Studio Code in ISE mode. It's interesting. That's as far as I'll go with it. The other extensions that are a must-have for me, I have a list of recommended extensions, but I also install Git history, which means from any file I can immediately see the file history and what changed. And then I also use git ignore, which lets me automatically pull templates for git ignore files, which I'll talk about in a bit more detail shortly. So briefly, I'm going to pull back to a PowerShell window for a second, just to talk about a limitation that you might not be aware of that exists in the standard version of Windows as it ships. There are two fairly critical modules in PowerShell: package management and PowerShell get. And those are used to install PowerShell modules and update PowerShell modules. And you can see that they both exist on a Windows system out of the box as version 1.0.0.1. They've both been updated several times since then. Windows ships with a version that's out of date, and it's so out of date it can't actually properly update itself, let alone any other module. So one of the first tasks you'll do on a new machine if you're doing PowerShell development is you need to update these. Chris Taylor has a script on GitHub, and I'm just about to publish an updated script that basically handles getting the most updated versions of these installed on a system so it's ready to go. But it is something you have to be aware of, is when you get your Windows machine out of the box and you start development with PowerShell, you have two key developments or two key modules that you have to update before you can actually start installing PowerShell modules or publishing them. Back to Visual Studio Code, and we have some key extensions. So I'm going to go ahead and open up the demo folder I prepped, which has a single script and then an extra file. When you open a folder in Visual Studio Code, it's going to talk to you about trusting the folder. If you trust the folder, this allows Visual Studio Code to automatically execute certain processes within the folder. So you can do various automatic code linting, quality formatting scripts. If you trust the folder, Visual Studio Code will use them. If you don't trust it, you get restricted mode and it won't execute anything without you doing so manually. It is one of those things where I do tend to function a little bit like the end users most of us have a troubled relationship with. I open folders in Visual Studio Code all the time and I autopilot click that button, which is fun. I caught myself doing it the other day. I cloned someone else's project from GitHub and that button came up and I hit the button to confirm. And then I thought about it and I was like, oh, I don't actually know what this code is and I've just trusted it. Which was, yeah, I felt like an end user. So Visual Studio Code, as it stands, basic editor, doesn't really do anything groundbreaking. However, there's a couple of things you can add to it for the benefit of Codium, E-I-U-M, for the benefit of David Spooner. This is the AI assistant David uses. He rates it quite highly. It's free, which is a huge benefit for AI-powered code acceleration. So check out Codium. If you want to throw, if you've got a bit of money to throw at it, I personally use GitHub Copilot. And it's basically like having a friend sat inside your editor, kind of feeding you what you're doing. So as you type your code or your comments in Visual Studio Code, Copilot or Codium will suggest how you can best structure that code. Has a lot less of the hallucination problem that exists on GPT, where it makes up commandlets. Tends to be fairly accurate. And I kind of recommend for novices that you check out one or both of them because they're well worth doing. So I've got a list of recommended extensions. The ones I've installed are probably the ones I would say are key. So Git history, Git ignore, PowerShell. If you're just doing PowerShell development and you want to store it in a Git repo, those 3 extensions will serve you quite well. So I'm going to look at the files I've got now. I've got a PowerShell script, PS1 extension, and I've got a settings file, which is a PSD one. This settings file is PowerShell script analyzer rules. So this tells the PowerShell extension via a module that's called PowerShell script analyzer. It tells it what rules I want to use to format my PowerShell code. So, things like avoid using global variables, avoid using aliases, make sure that braces and brackets are in the right place, make sure that things are called with the correct casing, a whole bunch of rules to hopefully make sure I'm writing consistent and readable PowerShell that doesn't do anything too crazy in terms of security implications. And it's natively understood. So once you have this script analyzer settings file in your project, so in the folder you've got open, it just kind of works automatically. You don't have to do anything to make it work. You just need the file. You can have this globally enabled through Visual Studio Code settings. So you can stick this, we tend to put it in like C/dev/standards. We tend to stick a bunch of these config files in there and just tell Visual Studio Code to look there for them. So I have a PowerShell script, and immediately PowerShell script analyzer is picking up the rules and giving me some feedback on my script. I haven't done anything. I've just put these 2 files in a folder and opened the folder and installed the PowerShell extension. That's the extent of the config I've done. And it's telling me that I should avoid using right host, but also that because this string is constant, it has no variables, it should use single quotes, not double quotes. And that's to prevent accidentally expanding variables or accidental behavior. I can fix both of these fairly easily by changing that one to an output and changing my strings to single strings so that PowerShell script analyzer is now happy according to the rules I've got. You've got a nice full terminal in PowerShell, which automatically opens to the current windows, so I can execute my script. And it kind of runs it and gives me any feedback. In this case, gives me an error because, this is not how you use outhost. So let's fix the error. And there we go. We have a web. Basics of script analyzer in Visual Studio Code. This file is linked in the resource guide, so when that gets shared afterwards, you can pretty much grab this file though from the Ninja One PowerShell module, the Halo API PowerShell module. Almost any PowerShell code I publish has got this file somewhere in its repository because I use it constantly. You can adjust the rules and they're fully documented. Microsoft have documentation pages covering PowerShell script analyzer and what each rule means. Most of them, the name is fairly self-explanatory. Some of them, the names leave a lot to be desired, like you should process for state-changing functions. I know what that rule means, but just by reading the name, it makes it less clear to me. I know what it does, and every time I read the name, I'm like, what do you do again? Who are you? There's a lot of rules. It's well worth using them, especially if you're coding alongside your team, because it keeps you all consistent. It makes sure you're all playing by the same rule book and you haven't got someone writing PowerShell in a completely different style, which makes it harder for everyone else to maintain. We installed Git when I was setting this up. So Git is a version control system. It's predominantly designed to be, whenever we think of Git, most people's heads will go to GitHub. GitHub uses Git extensively, but despite being the first thing most people think of when they think of Git, it's actually just a kind of Git consumer. It doesn't, they didn't create the protocol. They don't really do much other than use the protocol. So Git predominantly is a local tool. Yes, you can push and pull code to remote servers, but there's nothing inherently kind of remote or internet-based about Git. And what Git does is it creates a series of hidden folders that track your code, predominantly for controlling versions. It's not automatic, so it doesn't automatically work every time you change a file. You have to commit things. You have to tell Git that you want stuff to go into the Git repository. So I'm going to start by creating a Git repository, which is the git init command, or initialize. And that creates an empty Git repository in the current folder. So if I go to this demo project and view and show hidden files, we can now see there's a hidden folder here called .git, which has a whole bunch of files in it that track the state of that Git repository. This folder does everything for Git. If you've got this folder, you have a Git repository. Without this folder, you don't have a Git repository. So if you suddenly, if you wanted to uninitialize it, you can just delete the folder and it's no longer a Git repository. There's nothing more magical to it than that. We use Git because it helps us track versions. It provides a base for automation. When we commit code in, we can automatically run some checks to say, does it match our PS script analyzer rules? Does it pass tests? Is it documented? Does it work? We also use Git so that we can share code amongst ourselves with remote private Git repositories. And so we can publish code to the wider community with public Git repositories. So we're going to add all the current files to Git. So that's git add dot, which is Git add the current folder. Basically, start tracking the current folder. You can always ask Git what it thinks is going on with Git status. So it tells me that we're on the master branch. There's no commits. It has changes that haven't been committed, so it has pending changes. And that's the current status. We can commit those changes with a message, test commit. And then it tells me that I haven't set up Git yet, so it can't carry on. And that it wants me to set my username and email. So first time you use Git, it's going to do this exact thing at you. So git config global user email spidey@nyc.net and my name, Spider-Man. So now if I go and do that commit again, it works. Great. We have committed files. So again, status tells us we're on branch master. There's nothing to commit. The working tree is clean. Working tree is Git parlance for your current folder. This is telling us that our current tree matches with what Git thinks it should and that there's no outstanding files. If we change a file, then ask Git what the status is, it tells us that a file's been modified. If you've got modified files in Git, you commit them, essentially. Visual Studio Code has a built-in GUI for Git. So we can see M for modified, 2, which is that the number of problems that Visual Studio Code has identified, which is telling me that either I'm using the wrong casing or I'm using an alias. It can't decide on that one. Can stage files from the GUI with the plus button. Once you stage changes, they're ready to commit. So test commit 2. Do it through the GUI if you don't like the command line. And again, if we go back and get status, it's going to tell us it's all up to date because we've just committed a change. There's also Git history. So, one of the things about Git is that you can see what happened to a file in the past. And for that, we use Git history. So if I look at Git file history for this one, this is that extension that we installed at the first, the Git history extension. So again, tells us we're on the master branch, and it shows you all changes to that file, and you can view them. So you can see, what actually changed in this commit, but also, show me the version, show me the file as it looked at this time. And it'll just do it nicely for you in Visual Studio Code. No need to download any complicated Git GUI tools. No need to use any third-party services. This is all still just local. There's no server involved in this. We're just using this hidden folder, essentially, as tracking all of this information. It's this refs folder, essentially, that contains all the information about your current branch and any tags you're using. So what if we wanted to publish this remotely? You've got a few options here. GitHub is probably by far the biggest and most popular code hosting service. They have a free plan that gives you the ability to use pretty much all of their features, including private repositories. They used to charge for that. There's GitLab, which is an open source alternative to GitHub that also run a commercial hosted service on gitlab.com. There's Gitea. Atlassian have Bitbucket, I believe theirs is called. There's a number of different services. Microsoft have Azure DevOps, which formerly was Visual Studio VSTS something. It had a weird acronym, as is Microsoft. It had a name that no one can remember. Azure DevOps, I just about remember. So they all run off the Git protocol. There are also other version control systems, just to make life really, really kind of muddy. Git is probably the biggest and most popular. It's definitely the one with the most commercial appeal. There's also SVN, short for Subversion. RCS, which is built into Linux. Version control isn't new. It's been around pretty much as long as the Linux kernel. The very first version control systems were developed alongside the very early versions of the Unix kernel. They've gotten a lot more mature, and they can do a lot more now. But the basics of kind of version control has been around for a long time, and the need to track and version code. So if we wanted to add a remote repository to this one, in GitHub, in Visual Studio Code, you can just go publish branch. It will automatically take you through signing into GitHub, creating a repository, and basically handle the journey for you in terms of getting your code published onto a GitHub repository. I'm not going to do it live, unfortunately, this bit, just because I don't particularly want to create a GitHub repo for code that's never actually going to do anything. You can also add remotes with the command line. Git remote add. The Git convention is that your default remote is called origin, referring to the origin of the code, but you can name your remotes anything. I tend to call my remotes after where they're being stored, because I might have, it's fairly common for me at least to have one project that has the code stored in GitHub, Azure DevOps. So I tend to name them after where they're being stored, just so I can easily say, push this to GitHub or push this to Azure DevOps. You can authenticate to a remote Git server using HTTPS authentication or SSH. I tend to use HTTPS because it's easier than faffing around with SSH keys. And, it's fairly well supported these days. And it would just be, github.com/hermit.actual/spiderman.git. Something like that would be your remote URL. There's no validation to this until you first try and push to it. So you can add these without needing to authenticate until you actually use them. In terms of Git hosting options, if for the novice, definitely GitHub all the way. It's simple. They have an amazing set of guides and tutorials. It's free. You can invite your team, again, still for free. Private organizations only start costing you once you add a lot of users or start using a lot of advanced features. So you can actually have a private, completely hidden organization on GitHub that groups all your staff together so you can contribute to code and store your scripts and stuff. It's easy enough to authenticate to if you need to pull code automatically. And you get free use of Actions, which is GitHub's kind of automated pipeline tools. So you can say when new code gets added to this repository, run these tests or package it into a module and publish it to the PowerShell gallery, or check that it meets our code standards. You can run those automatically, and GitHub gives you all of that for nothing. Azure DevOps is the other one I'll talk about a bit. It's not free. There is very limited free functionality, but predominantly you need a Visual Studio subscription to use it. It does, however, have much better issue and task management. So if you're doing a lot of PowerShell coding internally and you really want to be able to collaborate and assign tasks and kind of track and pick apart what's going on, you'll have a much better experience with Azure DevOps. See David there helping in the chat. That's awesome. So I'm going to flick slightly over to a drastically more complicated bit of code and look at the Ninja One PowerShell module. If you've ever looked at this code, there are two things. The first one is I'm sorry, and the second one is that there's a lot of it and it's complex, and there is a good reason for that. But first, let me open it up. It's just Visual Studio Code telling me I don't allow it to open from TS folders by default. Yes, I trust it. I should. If I don't trust it, we've got bigger problems. So this is now my Ninja One module opened in Visual Studio Code, and there's a couple of things I'm going to pick up. First one is this code workspace file. So this is if you're sharing code with your team or publicly, and you want a way to group together all of your settings that apply to a particular project. You want to group together common development tasks like, run tests or build this. Code workspace file lets you define settings. So you can see I've stored the tab saves, told it to format on save. I've got a whole bunch of PowerShell code formatting rules. I've got some words for the spell check. I've also got some launch tasks. So these are, almost saved scripts, essentially, where I can tell PowerShell or anything else on the system to, execute a particular command with a single button. And they all get stored and shared with the workspace. So anyone who downloads this workspace and opens this file gets all of these settings applied. You can also use this to recommend Visual Studio Code extensions. So you can have it, when you open a workspace, you can say, we recommend you install the PowerShell extension and the Pester extension and the Git extension, and Visual Studio Code will just pop it up in the corner. It'll just tell you the author says you should install all these extensions, and you can click a button and it'll install them for you. It's actually quite nice. It's when it works, it's very good. So I'm going to look in some of the hidden folders at the top here, the folder starting with a dot. So this repository is used with Azure DevOps and GitHub. So I've got an ASDO folder for Azure DevOps, and I've got a GitHub folder for GitHub. So I've got an Azure pipeline for this that runs some build scripts and publishes it to the PowerShell gallery. So this is an automatic task. Every time I push this code into the main branch on Azure DevOps, it will run this task. So it'll pull a Windows 2022 virtual machine. It will run a setup script, and then if certain prerequisites are met, it will build and release the module to PowerShell gallery, all automatically. Nobody really needs to do anything. And there's a separate pipeline if someone made a pull request. So if it won't happen with this repository, because I'm the only one who does any coding on it from our team. But if anyone else on our team or in my Azure DevOps organization sent in a pull request, they would get a different task run that does some more tests and is a little more verbose with its feedback. So it'll tell them if they've made any errors. You can do the same on GitHub with their actions files, which live in this workflows folder. I don't have one for this. It's somewhere on my list. But these hidden folders let you control those experiences, and both platforms will automatically detect their relevant CI/CD files, continuous integration or development.
Hey, Mikey, sorry to interrupt, but I've been looking at the questions that we have, of which David provided a lot of them. And because you're mentioning pull requests, just to step back a little bit, and for folks who are maybe, well, like myself,
what is a pull request?
Knowledgeable on these subjects. Yeah, what the heck is a pull request? How does it work versus just doing a commit and push?
Yeah,
/
it's a great question. So we looked on the kind of the Spider-Man project. We kind of made some changes in Git and we committed them. That's only local. So you can do a Git push, and you can push it to your remotely hosted Git infrastructure. But if you were looking at my PowerShell module, for example, and you'd spotted an error, pretty likely, or a spelling mistake, even more likely, and you thought, oh, I want to fix this, you can fork the repository, which is this little button up here, which creates a copy in your GitHub account. You can make any changes. And when you've made changes to someone else's repository, contributing them back means submitting a request to have them pulled or merged into that person's repository. So if you made changes to this, you'd make them in your fork, so in your copy of the module, and then you'd submit a pull request, which lives in this section. There have been 6. And a pull request is essentially someone asking, can I merge this code into yours? Would you like to make this change? So if we look at this code, this pull request, and what changed, we can see that they found an error where I hadn't renamed a variable for a commandlet. They fixed it, so they updated the variable. They fixed some other attached code so it worked properly, tested the change on their end and saved it to their copy. In this case, you can see their copy here. And then they submitted a pull request saying, I've made this fix. Can you merge it? Can you put it into yours? And yeah, in this case, I reviewed, I requested some changes, which GitHub lets you do. So GitHub lets you propose changes. In this case, they were using a short form alias, and I wanted the full form. So I made a suggested change. They accepted the suggested change. It got merged. That's it. It now exists in the main branch somewhere. And that's a nice, simple pull request. You can get more advanced. So when we were talking about those pipelines, those automated actions and jobs, you can run these automatically on pull requests. So you can have it automatically run PowerShell script analyzer or automated tests, and require those to pass before someone's allowed to merge it. Pull requests are sometimes called merge requests, depending on what platform you use. I think Bitbucket and GitLab call them merge requests. Pull request is a GitHub thing. It means the same thing. You're requesting to merge your version of the code into their version of the code. One of the things Git is pretty good at doing is duplicate or working out conflicts. So there won't be any on the Ninja 1 module, but there probably will be on the Halo module. There will probably have been 1 or 2 conflicted merges on this one. Have a look and see. I'm probably not going to find one just offhand. But Git will tell you when there's a conflict. You'll actually get a line, like you see the kind of added commits. You'll get another line that tells you about conflicts and asks you what you want to do. And yeah, you have standard options. You know, you can go through line by line. You can resolve it manually. You can let Git try and resolve it, which is always interesting. Often fun results from that. So yeah, pull requests, cool. Undoing stuff in Git is probably a good one to cover. So if we look at the commits we made, if we look at test commit 2 briefly, and when I added this, I introduced some problems into the file. I introduced an alias of a command or something that has the wrong case. So I shouldn't have done that. The original implementation was great, so I want to undo it. If I want to undo it with the GUI, it's nice and easy because I can go into the file history. I can look at the version I want, which is this version, and I can just tell Git to reset to this commit. 2 types of reset in Git: soft reset and hard reset. A soft reset tells Git reset to that version in the Git history, but leave the file as is. Don't change the file. So then Git status will tell you that you have pending changes. So if we do a soft reset to that version, we can see that it's not changed the file, but Git thinks the old version of the file is still there. So it's showing a pending change, and Git status will show that as well, that the file's modified. Not what we wanted in this case. We actually wanted to go back to the file completely. We don't want the changes. So that's a hard reset. So a hard reset changes the actual file, completely erases that extra commit from the history. It's like it never happened. Git is a distributed system. So everybody who clones, which is downloads, that Git repository has their own Git folder and their own Git history. And when you push or pull to a remote repository, you're essentially trying to match up those histories. So if I made some changes and David made some changes, and we both pushed them, provided there are no conflicts and we haven't changed the same file in the same way or in close but not quite the same way, there'll be no conflicts and it'll just silently merge all the code together and, you know, be quite happy. If there are conflicts, we have to resolve them before it'll let us push. That's okay still. But if I've undone a commit and David still has it, then something has to be done when we both try and sync to that remote repository. So by default, when you revert a commit, which is what would happen when you reset, when you revert a commit or remove a commit, most remote repositories won't let you push it unless you force them to. So you do git push force. And that's essentially telling Git to forcibly overwrite the history. That'll still cause problems for David, because when he tries to push, his version of what he pushes won't have, or will have a commit that you've just kind of purged. So he'll get an error. So this process of resetting also works with remote repositories. So this is where the GUI tools let you down, because whilst the GUI tools will let you view the remote branch and reset, they won't necessarily help you out when things get stuck. And for that, it's worth remembering the command line version. And there's a cheat sheet in the guide that has this on. So you do git reset hard, and then you'd provide the name of your remote. So in our case, we called it GitHub, just for example. So what this would say, if I ran it, and I'm not going to because I don't have a working remote, but this is telling Git to do a hard reset. So just grab the file versions that exist on GitHub and drop all of our local changes. So it resets you to a known good state. If you use it without hard, you do a soft reset. So if we look at the example with David, where David has local changes, wants to push them, but I've made changes in the meantime. If you do a soft reset, David will reset his version of the files of the Git history to the remote version, but keep his changes to the actual files. So he doesn't lose his work. He just has to commit it again and push it back up. So Git reset is a great way to undo things, to go back to a known good state. It's also a great way to kind of remove local changes and reset to the remote state if your changes go out of sync with the remote changes. In terms of extensions working with Git, the only one I really use is the Git history. There are other extensions for Git. I used to use Git Lens, which is by the guys behind Git Kraken, which gives you, for some people, a much more friendly GUI for Git in Visual Studio Code. It's almost always in the recommended section in the Visual Studio Code UI, and it has a lot more information about your commits. I find it too busy personally, but it's worth people knowing about that it exists. It lets you do kind of line-by-line histories of files, visual file histories, and they have a pro version and a paid plan, and you can search by commit and message and file. It does a lot more, and it definitely has a few more features for working with remote repositories. So if you're new to Git, then you may find Git Lens more useful than the built-in. Personally, I prefer the simplicity of the built-in options. You know, it shows me when I've got pending changes, it lets me fix the changes, and it lets me kind of do a sync with the remote version. So it lets me, push and pull to the remote version on GitHub without really having to worry too much about it looking fancy. It just works. I had issues with Git Lens not working properly a few times. So, use at your own risk. I'm going to uninstall it because having it installed is making me twitchy. Oh, yeah, cool. Close. So one of the advanced questions was deciding where to break things up. So how do I decide what is a separate repository and kind of where the trade-offs are? That's a good question. I think somewhere in my head, I'd like to think I have a system. I'd like to think I kind of break things up where it makes sense. You can kind of see from my repositories that most of them are single task focused. So Ninja One module, Halo API, PowerShell module, Microsoft Graph, Mail module. So they do tend to be sort of single task focused. But then if I look at my local approach to kind of where to split repositories, I've got a bunch of kind of fairly clearly delineated repositories. And then I've got some that are really just random collections of scripts like this one in folders. So I don't know that I have a strategy that I'm going to sit here and say you should do it this way. I feel like once you get into using Git, it should become apparent where to draw that line and when to start a new repository for something. If you're feeling like it's not, what you're doing is not related to other stuff, then you might want to split it. If you feel that the way you want to work is just to have all of your RMM scripts in a single repository and just work that way, it's not a bad thing. It's not terrible. So yeah, do what seems like it works for you, really, within your process. In terms of organizing repositories for internal versus external audiences, GitHub has the concept of public and private repositories. So when you create a new GitHub repository, you're asked if you want public, private, or internal. Those are the three types GitHub supports. So briefly, public repositories are visible to anyone. If we look at Ninja One module, public, anyone can hit that URL and view it. And you can see a lot of information about it. You could, if I had actions running, you could see them. You can see issues and pull requests, and there's a lot of information you can see because it's a public repo. Private repositories are limited only to the people you add. Internal repositories are limited strictly to the team that owns them. So if I created an internal repository on the kind of homotextual namespace, only I can access it because it's a user. If I were to create it on the Ninja One community namespace, then anyone who's a member of that group can access it. I tend to, that's about as far as I go with how to organize for internal versus external. We have a bunch of legacy internal stuff on Azure DevOps because originally we started with GitLab probably back in 2013. So we have our own GitLab server, which has just been turned off, shut down, because it's all now in Azure DevOps. And we're actually moving a bunch of stuff out of Azure DevOps and into GitHub private repositories. So for us, it's kind of all around GitHub. We used to do internal stuff was on Azure DevOps, public stuff was on GitHub. But when GitHub made private repositories free, we're going all in on GitHub really for this now. I've mentioned a couple of times pushing and pulling repositories, and it's worth understanding what that means. So a push is take my local Git history and changes and send them to the remote server I've configured, and that takes the form of git push and then the name of the remote. So GitHub or Origin or whatever, and it pushes to that specific remote. In GUI terms, you'd come into the source control view, and then you'd go push, and it'll try and push to the default branch, or if there isn't one, then it'll ask you to set one. And that when you set the default branch, you tell it where it's pushing to as standard. You can also do it kind of per a bit more manually, push to, select your remote, and then it'll try and do it. And this is going to fail because I didn't actually want to click that. Never mind, we'll wait. A pull is the exact opposite. So a pull is saying, look at the remote repository and give me the changes there in my local copy. So pull the current state of what's on, in our case, GitHub, into my local copy. Fetch is a little bit like pull, but it won't give you the changes. It'll just tell you if there are changes. So fetch is essentially querying what is the status of the current repository, or of the remote repository. So combined in Visual Studio Code, you'll get a sync button. If you have a live remote, I don't actually have one. But if you have a live remote, you'll get a sync button. And if you sync with Visual Studio Code, it will first do a pull to check if there are remote changes it needs to integrate, and then it will try and do a push, and it'll tell you if those things fail, essentially, or if there are any blockers or any merge conflicts. But a sync is just doing a pull, a pull and then a push. And there's a reason it does that order, so it doesn't overwrite remote changes just with a blind push. In terms of my kind of preferred approach, there are some programs and tools out there that I'm aware that others have used or use that let you map a remote repository as a drive letter. I've never gone down that route. Git has always, since it was first released, has always had a system for working with remote repositories as standard. It's designed to be a distributed version control system. Everyone has their copy of the Git repository, and it has commands for pushing and pulling. Using it as a drive letter is essentially using the remote repository directly and kind of committing every change as you go. And that's not really where Git shines. You're using Git almost like OneDrive in that sense. So yeah, I very much am a bit of a purist in that, I add remotes and I push and I pull to them and I commit changes in batches as I need to. And I'm also, a little bit of a opinionated when it comes to the right way to interact with Git. Me, opinionated. I hear gasps. I can hear them through the text chat. You're all surprised that I have opinions. I interface with Git pretty much exclusively through the command line. I will occasionally, if I'm feeling particularly charitable, I'll come and give this a whirl and stage some changes and then kind of push and publish changes through the Visual Studio Code native GUI. And then after I've done it once, I realize that actually, Git add everything, Git commit with my message, and Git push. It's quicker. I'm strongly opinionated, but the GUIs are slower. And if you're doing this regularly, or if you're flitting between 4 or 5 repositories in the case of a day, which I will frequently do, you'll start to remember the common commands, and they're quicker. There's a bit less feedback. That's the trade-off. You gain speed and you lose helpful information. I'm gonna try briefly and cover the kind of what I listed as the bonus questions. So the first one was, how do you create a PowerShell module and make it available to the public? So very briefly, a PowerShell module is essentially a combination of 2 files. One, a module manifest, which is a PSD1 file that has a bunch of structured metadata about the module: name, version, GUID, publisher, whatever functions it makes available, any dependencies it has, if it depends on certain binaries, which the Ninja One module ships its own, has 3 custom binary classes. License information, URLs, the whole host. These modules are understood by predominantly 3 tools: the PowerShell gallery, which is where public modules are hosted; the PowerShell get module, which interfaces with the gallery to download and install module; and its successor, PS resource get. They all pass these manifests to understand about the module and what version it is, and how to interact with it, how to install it properly. The second key file is what's PSM1 file. I don't have one for the Ninja One module because it's generated on the fly during the build. But the PSM1 module is responsible for containing the module code. It could just be one giant long list of functions, or it could be, depending on how you architect your code, it could be a function that loads other functions. There's no wrong or right approach. I've moved to this monolithic approach because it's what the most of the PowerShell community do, is they stick everything together in one giant PSM1 file and be done with it. I'm still coming to terms with, whether or not I want to stick with that, but that's what I'm doing for version 2. Once you've got this, and you've got PowerShell resource, PS resource get, or the PowerShell get module, you will have the publish module command, which essentially takes a path to a folder and publishes it as a module on the PowerShell gallery. So if we look briefly at the PowerShell gallery, we can look at the Ninja 1 module. You can see Luke's Ninja 1 docs module there, which, slight shout out. It's amazing. For lightweight, just if you just want to do documentation stuff automatically, it's a really solid effort. Absolutely love that. It's very task focused, but it's cool. So if we look at the current version, RC4, look at the file list, you can see I've got a PSD1, a PSM1, and the 3 binaries. So from that, in this entire source tree, everything that's not essential to running it gets dropped during the build. Everything gets stitched together into one file, and then we bundle it up and automatically, programmatically kind of push it to the PowerShell gallery. And that then handles making it available to download with install module. And if you've ever used the install module, you're pulling from the PowerShell gallery unless you have a custom feed, essentially. Install PS resource is the new version of that from PS resource get. It's significantly faster and less likely to get stuck. So it's worth converting if you do a lot with PowerShell modules. As for making it kind of, making it known that it's available, that's, there's no automatic system in PowerShell when you try and use a module that says this has been updated. You may have noticed when you launch PowerShell, it has this kind of install the latest PowerShell line. That's a custom check. I haven't gone to that level, and I don't know if I ever will. But there are modules like the As, Set, or Microsoft Graph that do automatic update checks. So they reach out to the PowerShell gallery programmatically whenever you run a command and check if there's an updated version and show you a banner. But by default, PowerShell won't tell you there are updates. You kind of have to check and go and read about it. So it's worth noting if you are installing modules that they won't tell you when updates are available. You can you kind of have to go and check. There's no update feed available. And the second and final bonus question was how do you decide what scripts and projects belong on GitHub versus internal, and what about code snippets? It's a solid, you guys are good questions. Everything for us is moving to GitHub, internal versus public stuff. We have a couple of weird splits. So if we take the Ninja 1 module as an example, this is the public repository. I have a second private one as well, which is where kind of early development code goes, or any customizations we might make for internal use. Ninja has a few hidden or beta or kind of alpha API endpoints that aren't ready for public consumption, but that we might still use. So those may exist in our internal version for months or years before they get released, if they ever get released. So yeah, we maintain a private copy that we use for some of our own automation. I will say, if there are modules you use a lot, it's probably worth maintaining a private copy, just so you can be sure that you're getting code is okay, that works, and that you trust. And hosting private repositories and kind of building it yourself on demand is one way to accomplish that. Snippets, I use GitHub's gists. So GitHub has, if I was logged in, there's a system in GitHub called gists, which is for publishing little code snippets. And again, they can be private or they can be public. So you can publish little snippets of code. And that's pretty much it. A bit of a whistle-stop tour. Probably went a little too deep on some things and just didn't cover other things. But yeah, that's... I got through most of what I wanted to cover. I hope it's been useful for someone. And yeah, are there any key questions come through the chat?
Jonathan's here.
Yeah.
Yeah, I'm still here. I'm still lurking around. Mikey, thank you so much for doing this.
worries.
I'm going to bring up. Yes, you not only did you take time to do this, you took the time to document all these helpful resources, these Visual Studio Code extensions and whatnot. And so we are including links to this doc in Discord and on YouTube, so anyone watching can have access to that. And I know that you also mentioned, hey, this would be, there's some follow-up topics. Obviously, there's so much more to discuss in so many different directions. I know documentation was kind of one area, but yeah, I mean, we've even talked about making, PowerShell series kind of an ongoing thing. So
there's a lot to cover,
great.
Yeah, it would be cool.
There's a lot to cover. Absolutely. But thank you, everybody, so much for joining. And Mikey, thank you once again. And obviously, everyone knows where to find you.
Yes.
If anyone is watching this after the fact, discovering us via YouTube, we'll also include a link to join the Discord server. And Mikey is rarely away. He's always just like a quick tag away or a quick question away. And thank you, Robin, for adding the link there. And so the conversation can absolutely continue.
And yeah, the community is probably the single best thing about Ninja, and probably one of the key things that differentiates Ninja, for me at least. I've had moments in the past when I've kind of looked at Ninja and looked at other tools out there and thought, yeah, maybe I should make a change, or Ninja just doesn't quite do what I need in this circumstance. And the community, and Jonathan as kind of the steward, at least from Ninja's end, on the community, along with Stephen, or F Society as he's known on Discord. Between the two of them, they've probably pulled me back from the brink of changing away from Ninja several times. Their commitment to the community is amazing, and it's the place every Ninja customer should be, hands down. That community is Ninja's USP. I don't care what they add to the product. The community is their USP. It really is.
Wow. Well, I appreciate those words. And I mean, it definitely is, it goes beyond, obviously, me and even Steven, that man who never sleeps. It definitely goes into everyone, more people, Robin and Brittany on our side, but then, man, yourself, David, so many others, Mike, Ogle, everybody. It's been amazing to see it grow, like I mentioned, and it's an amazing place. We just want to be, I think stewards is a great word of it. I think that there's a lot of people sharing a lot of valuable info, and we just want to be the best stewards of facilitating that as we can.
It's got a pretty cool origin story. Like it started as a completely unofficial thing, and you guys have kind of adopted and embraced it in a way that I don't think I've ever seen another vendor even attempt in their dizziest daydreams. It's been awesome.
It's been a great ride, and really just getting started, I think, in many ways. But Mikey, thank you again.
There will be a follow-up to this at some point when we can arrange it, which will kind of cover the topic that's probably closest to my heart, which is how I approach documenting the PowerShell I share publicly, both in terms of code comments, but also the whole docs site for the Ninja 1 module and Halo modules is pretty much 99% automated, and there's a cool kind of story and journey around how that fits together, and which bits of it are easy to reuse. And yeah, I kind of want to talk about that at some point.
Absolutely. We'll get it on the books. And Robin, is it okay if you come back on for a second? Quick shout out on an update for the March Madness scripting.
Oh, yes. March Madness is going strong. Our voting closes tomorrow. So if you have not voted for our final two, or our semifinal 2 matchups, you can do that in our Discord. Let me pull up the Discord thing one more time, so in case you haven't seen it, there you go, to join Discord. And that is in our Scripting Madness. And then we will, on Thursday, we will announce the final matchup and who's won. And then we will have until the next Monday to find out who has won March Scripting Madness. So Hope your brackets look much better than my brackets look for the actual basketball version of March Madness. And thanks again to everyone who submitted scripts, and then Mikey, since you're here, thank you publicly for helping me, because I was like, I don't understand. So Mikey and David, who's in the chat, they really, really helped out, along with some other people internally. So yeah, we're coming up to the end, but you can still vote. Voting is open for this semifinal round until tomorrow.
It's been awesome, like
Yeah.
seeing people we expected, like the people I expected from the beginning, getting involved and sharing stuff, but also people who I've kind of never seen share a script before got involved. It's so cool.
That was the point.
Yeah, it did everything I hoped. It brought people out to share code.
Yeah.
Nice.
Absolutely. And we do have, I mean, this is the trophy that's going to be going to the winner.
Nobody told me in advance there was a trophy. I renounced judging. Can I enter still?
We have a last minute entry, yeah, in the final. The real boss.
Ninja 1 module.
Yeah. But yeah, well, I mean, we should absolutely, after we crown the champion and everything, go through and do a quick live stream to just talk about some of these different scripts and some of the things that you're looking at when we're thinking about like the judging criteria and stuff like that. So I think we got a couple of streams to add to the books.
Cool. Follow the stream.
All right, everybody. Thank you once again, and take care. We'll see you online.
See you in the Discord.
Bye, everybody.